So these are all what actually we had gone through. Uh, we learned about basic variables, typecasting, a little bit of error handling, again typecasting along with logging. We also had a discussion with the list, how to create a list. Uh, this is how we have created a list. We also iterated through the list. We used if else statements, switch case, and also we did match case, which is quite different in Python. Match case, a lot of patterns. And we were discussing about a basic loop. While working with loop, we also had started uh, splitting it into different packages, and then how do you really create a package, work with the package. Little bit. I'm not saying very in depth, but we had gone through that. So the next one is set. We will discuss about set. Set in Python. Set is quite different than list. Okay. So basically, uh, set doesn't have duplicates. What is called a set? It's a similar to mathematical set. Okay. That means no duplicates and order is not guaranteed. One thing to very, very important is order is not guaranteed. And generally set are very fast operations. Okay. Uh, because initially set uses kind of a hashing technique. Hashing. So hashing is a technique where a secured hashing algorithm kind of a mechanism is used for the sets. We'll discuss about that little later, but this is what the set is. So you cannot have duplicates where you can have duplicates in a list. For example, you can create a list. You can have duplicates. This is what the list is. When you print the list, you can see that you can have duplicates. Okay, you can have duplicates. This is a list, it's not a set. Whereas the set is whenever you create a set, first thing what you do is you create a set. Let us say S is a set. You give it in the curly braces. The moment you give it in the curly braces, let's say 1, 2, 3, 4. Again 1, 2, 3, 4. Sorry. Again 1, 2, 3, 4. You see that this is a set. What I said, what I said, you can create a set, but there are no duplicates. Okay, there are no duplicates. So what happened? Print line, sorry, print yes. If I print yes, Python 6 for you see that only 1, 2, 3, 4 are printed. Even though you have taken multiple elements, you got to print only the 1, 2, 3. Okay. This is what you can also create a set in a different way. Let's say that assume that this is S1, this is S1. I want to create a set called S2 equal to set of, you can give a set like this. Set is a function. Set is a class, sorry, set is a class. You can create the class that is an unordered collection of unique elements. See. So this builds an unordered collection of unique elements. Wherever you see something like a keyword called set, you can also. The reason is, let's say I want to create a so print of S2, it prints the set. For example, you want to print of sorry. let's say that I want to give S3 equal to this. This would never create, sorry, this would never create a empty set. It's the problem. The reason is this creates a dictionary. This is a dictionary actually. Because for both set and dictionary, you use curly braces. That's the reason whenever you create a set, if you want to create an empty set, you need to create like this. So print type of S3, when you get it, it's a dictionary. That's the reason whenever you create empty set, S3 equal to set of you do. This would create an empty set. Sorry, creates an empty set. This creates, you can see that the difference is that would create an empty set. So set is unordered. Whenever you create a set, it is obviously is not an ordered set. It would be an unordered set. Okay. So order may vary. That means that's what. Let us say that I create a set S3 equal to, for example, I can give 3 2 3 1 2. Okay. Print of S3. We don't know because internally it uses a technique called hashing. You see that 1 2 3. You don't get, it's not like always 4 5 6 8 7 or 9. It doesn't mean that you get always in order. You, even though you don't give in order, you may get in order. Okay. So there are a couple of things, right? You can create a set and all. So unique elements, basically all these things are unique elements. The order, whatever you give, the order may vary here and all. You can also perform some kind of add, remove kind of operations. For example, s dot add of, sorry, s3 dot add of maybe some value. Okay, s3 dot remove of, for example, some value. This would raise an error. This would raise an error. You need to check what error it is. Because the element is not there, you try to remove an element, the element is not there. So when you try to remove element, you see that key error. We call it as a key error. That means you are trying to create an element, sorry, you are trying to remove an element, but the element is not available. So it would create an error. So what do? You create try and raise. So what is that? Is it try and raise? If you really look at to create a error, you can see try except, sorry, raise is different. Try and except, you give, where is it? You give try except. Okay, inside the accept, what do? You accept, basically you accept what? You accept an error. What is the error? The error is accept value error. Similarly, we have something called accept key errors. It's going to be accept key error. You can say maybe print key to remove key is not available. You just write like that. So what exactly this is? This is going to remove, is going to raise an error. You need to read actually these functions. Most important thing is you need to read. Remove would remove. If it removes, it return none. Remove an element from a set. It must be a member, right? If the element is not a member, raise an error. This means this function raises an error. You need to catch that error and then you need to handle that particular error. Want to raise it, you can raise it to the next layer, but here you have to raise it. So you can add an element to the set, but if the element is, uh, error. For example, let us say that I don't want to raise an error. Let's say that okay, here remove the key is not to remove key to remove key is not available, and then you printed it. Now I would like to again remove as 3 dot. There is something called discard. Discard is a save function. Unlike set.remove, discard method does not raise an exception when the element is missing from the set. This is a better one. Let us say I want to discard 110 and then I print as 3. Discard is not like remove. If it is not available, what would happen is it does nothing. If if element is not available, no ops. No ops means no operation happen. So discard is a safe operation comparatively than this. Okay. So you can also check a member whether a member is available or not. We will see that. Okay, we will see that. Uh, Interestingly, there are a couple of things that are available for sets. Okay, there are a couple of things that are available for sets. For example, I create a set A equal to 1, 2, 3. I create a set B equal to, for example, 3, 4, 5. Sorry, I am writing Golang syntax. So there is something called, there are bitwise kind of operators, but using those operators, you can perform union operation. So you can do print maybe C equal to A union B, print C. This is a union operation. You see 1, 2, 3, 4, 5. What is union? 1, 2, 3. 3 is 2 times. It does the union operation. Particularly data analytics and all people perform these kind of operations a lot. 1, 2, 3 union operation. Interestingly, you can also perform sets are very, very useful, particularly in the area of analytics and learning. There is something called intersection. I want to do intersection. So C equal to A intersection B. This is how you have to use intersection. So print C. Similarly, you can do the difference between A and B. You can say difference C A minus B. This is the difference. It looks like what is there A minus B with respect to list. Yes, you can do minus B because it's going to give you some kind of, you see that A minus B. So what is the difference? A minus B. There is also symmetric difference. This is not a symmetric difference. This is not A minus B. You can get I think 1 and 2. 1 and 2 A minus B. You got it. I think it does the 0 0. After that 1 and 2. It does. Okay. A minus B is gone. You can also do 1 B minus A. Intersection. If you see what is the common thing between A and B, it's called 3. So you got 3. Union 1, 2, 3, 4, 5 because these are all the union variables. You can also do the symmetric difference. This is not a symmetric difference. You can also do the symmetric difference. Symmetric difference means C equal to A of B. This operator you have to give. You can see the symmetric difference here. What is different variables in A and B? 1, 2, 3, 4 because it is similar to union, but it only gives a difference. Common variables are removed. Common variables are removed. Intersection only common variables are shown. Union only one of the common variable is shown, right? Like that, it does that. Okay. So you can also, what you can do is you can take a list and you can convert a list to a set. Let us say that list equal to 1, 2, 3, 3, 4, 5, 1, 2. This is my list. I can create a set equal to set of list. This would convert a list to the set. That means all the duplicate elements are generally removed from the. So remember that sets are very useful actually. Sets does wonders in Python. Set does wonders. Okay, so that's something. You can also have a set with the different variables. Okay, you we have been already doing that. We can also have a set with normal numbers. We can have a set with number. Important thing is one of the important things with respect to set and list is you can create a set with any kind of variable. You can create a set. Let us say that s equal to uh, true 10, 10.10, hello world, maybe a character, and also a tuple. This is a set. You can print a set. That means any kind of value you can give in the set. You see that you got the tuple, you got the true, you got 10.1. Okay, you got 10, you got a, everything you got. But you cannot give a list. I think, let me check it. Yeah, you cannot give a list. Why you cannot give a list inside that set is list is mutable, set is not. List is mutable, set is not. Okay, that is one of the uh, things that we need to understand about the list and set. List is mutable, set is not. So you cannot give a list inside the set. But you want to create a list from a set. You want to create a list, a set from a list. Okay, and then it gives. You can do that. For example, you want to create a list. You can create a list and you can create using set function. This is fine. This you can do, but you cannot add a list over here because systematically there is some issue that list and set are two different settings. Okay, set is immutable, list is mutable. That means you can go technically go into any element of the list and then can change it. Okay, and one more thing is if you really look at it, this is very important difference. When you say a minus b, so a has 1, 2, 3, b has 3, 4, 5. When you say a minus b, what you are telling is we call it as the set difference. This is called as the set difference. What is the set difference is take all elements from A that are not present in B. A minus B means set all elements, take all elements from A, take all elements from A, those are not present in B. It doesn't mean that it doesn't mean that take all elements, it doesn't mean that take all elements from A and B. That's very, very important. It doesn't mean that take all elements from A and B. It means that take all elements only from A. Semantic difference is what actually you want to use. Semantic difference is different thing. Semantic difference, symmetric, sorry. Symmetric difference is something. Symmetric difference means you take the difference between A and B. Whatever is not available in A and B would be shown here. Maybe 1, 2, 3, 1, 2, 4, 5. It avoids the elements that are possible that are available in A and B. You know the intersection and you know the thing. Okay, that kind of things you have to you want to iterate through a set. For example, iterate through a set. Let's say I give set S equal to maybe 10, 11, 1, 2, 3, 4, 5, 6, 7, 8, 9. For example, I I take a set like that. If I take a set like that, I want to iterate through the set. The best thing is for each item in S. Right now, I'm doing, sorry, I'm not doing anything. I'm sorry. In S, I'm not doing anything. I just print off item. You want to print a sum of numbers, you can do. You want to do sum of numbers, you can do. Let's say sum equal to 0. You can also do sum equal to sum plus item, and then you can print sum is sum. You can print sum of all the elements. Sorry. You can print sum of all elements from the list set. This you can do. 66 is what actually sum. You can iterate through the set. You can iterate through the set. But you cannot change the element from the set using any kind of uh, you cannot. Let us say that I want to find out only the elements which are even in the set. Okay, find even elements, print only even elements from a set, for example. So what I do for item in S, if item modulus 2 equal to 0, then print item. So what I'm doing is, if at all the item is modulus 2 equal to 0, I said print the item. So this is what actually you are trying to do, print all the elements which are even numbers. You got 2, 4, 6, 8 and 10. Okay, this is iterating through the set. You take a set, you take each and every element from the set, you iterate it, and then you perform some kind of operation, but you cannot change. You cannot change because set is quite different. Okay, you can also use an iterator. Iterator is something like you can also use an iterator in the set. There is a separate syntax for iterator. For example, iterator equal to iter of s. This is going to be the iterator. Iterator means it iterates to the next element. Iterate, it is the iterate to the next element. For example, print of next of it. Again, next of it, next of it. It would iterate and then it would print the elements. You can see 1, 2, 3. Okay. How do you get this? You can see 2, 4, sum is there. After that 2, 4, 10. This is for the thing. This is a iterator. So you take an iterator. Iterator is you convert it into iterator. From the iterator, you keep on getting next, next, next like that. Okay, what the iterator return? You need to check what iterator is going to return. You can also do that. You can check that what iterator is going to return, and based on that, you can say iteration is big O of n because the number of elements that each element access is fast because of hashing. Iteration is big O of n. Big O notation means for the time-based complexity, big O of n. That means as many number of elements are there, it would iterate those many times. Set is a very good example, particularly in Python. What set does this? Set would hash it and then make it possible to iterate. Okay, this is going to create the iterator. If you see that next, return the next item from the iterator. If default is given, all the iterator is exhausted. If you see, it is returned instead of raising stop iteration. There is something called you want to iterate. You want to iterate until all the elements are iterated. Okay, what you can do is, for example, there are only three elements in the thing. The problem with the iterator is, let us say that I create a set s equal to 1, 2, 3. I create iterator it equal to iter of s, and then what I do is I create these many iterations. But actually, iterator can iterate only until the iterator can iterate only until it is true. But what you are doing, you are telling next you get 1, next you get 2, next you get 3. After next, you don't get anything. So what would happen if you don't get anything? If you don't get anything, it would give you error. Obviously, it gives an error. So there are only three elements, but you are trying to iterate for more than three elements. So what actually we can do is we can some people, I think this is not necessarily to do that. You can easily use a normal this kind of a loop. But what some people do is they use while loop even with the iterators. For example, let me take this. Yeah, let me take this. I take this here. What I do is it is next of sorry, iter of x. I get the iterator into it. It's an object. Basically, it's an object of iterator. And then what they do is while true. That means while true is always true. While true is always true. But how do you make it false? You cannot make it false, but you need to break it. While true, what you do is x equal to next of it, comma, there is something called none. That means what you are doing is, if the iterator is not going to give any kind of a value, you say that give the none. This is a default value. If iterator is not going to give any value, you can give here. You say that give none. And then from here what you do is, if x is none, you can say break. You can print x. So this what you are doing is you are trying to iterate unconditionally. You're trying to iterate unconditionally. If at all the x becomes none, because it is not going to return any value, it returns none. If at all it becomes none, whatever, whether it is a none or it is the value, you get into x. If it iterates, it gives a value. If it doesn't iterate, it gives none. The moment x is none, you say break. Otherwise, what you are doing, you are just printing x. Like this also, you can iterate. See that it has iterated from 1 to some value. The moment it find none, print found none. So breaking the loop. For example, break is something called to break the loop. Break breaks the loop. You see the found none, so breaking the loop. So like this also you can iterate, but the best way is, as simple thing is this one. Simply iterate through all the values, and then get the iterate instead of using the iterator. Okay, it's a bit. You can think iterator like a stream cursor. What you can do is you keep on reading data until what? Until nothing left. Stream is flow of data. If you take a look at any kind of stream, okay, you if you know the concept of streams, what is the concept of streams? Streams means some kind of iteration. Stream is an iteration. Sorry, stream is continuous flow of data. Anywhere you are using a stream means you keep on getting data. We say Kafka streams. We have different streams are there, pipeline, stream pipelines. That means you don't know the end point. So when do you really use iterator? One of the best use of iterator is you don't know the end point. You don't know how many elements you got to get. When you don't know how many elements you got to get, the best approach is you use an iterator. Keep on getting elements. Keep on means how long? Until there is no element to be read. You kept on getting elements. That's what actually the iterate. Iterate is a very good pattern. We will see that. I mean, even with the kind of data pipelines, you are using Spark and all these kind of streams comes into the picture. Generally, many streams they implement something called an iterator. Okay, so that is what actually called these are the basics. Set is also. I mean, these are the basics. Why you need to know? Because unless until you know this, you cannot really understand the concepts of Python. So what is called a set? You know that set is the unique elements you can have. The most important thing is set is also implemented like a dictionary. Dictionary contains keys and values, but set contains only keys. That's how you have to think. Okay. So basically it contains hash table. Hash table is nothing but array of slots. Each slot, array of slots. Okay, we call it as slots. Each slot can be empty, occupied, which contains an element, or we call it as a dummy, which is got deleted recently. Okay. What actually it does is it does the hashing. S equal to 10, 20, 30. For example, if you give a value, it does the hashing. Each element, whatever you are trying to insert into the set, each element you are trying to insert, it hashes this value, it gets an integer. This particular integer is mapped to an index. That means it creates some kind of slots. Okay. For example, you say hash of 10. Hash of 10 would get some kind of a value, and that particular value is hash. That hash from the hash you get some kind of an index. How do you get an index? We do something like the hash divided by table size. Hash modulus, it does the modulus operator. Okay. So each table can have some slots. Okay. Each table can have some slots. I think 8 slots would be there for each table. Uh, I think so. That's how the hashing. So hash is very important. It does some kind of hashing. That's the most important thing. Lookup is also very fast. So lookup is also very fast. You can say, for example, if 10 simple thing, if 10 in S, you see that if 10 in S, that means 10 is there inside S. It's very fast operation. Why? It compute 10 hashing. By that it understands the index. It jumps to the index directly inside the slot, and then it gets back the value from the slot. It's pretty easy. Okay. So, for example, you want to remove an element, what it does is it doesn't clear the slot, but what it does is they call it as a tombstone. Tombstone means it puts something called dummy kind of a thing inside the slot. Okay. There is also resizing. Generally, for dictionaries and all, there is a concept of resizing. Resizing means whenever it reaches two-third of the uh, growth, I mean two-third of the slots, automatically the table size increases, generally doubles the size. For example, 10 elements are there, it would become 20 elements. And then all the elements are rehashed. Rehashed means again the number of elements increases, the number of elements increases inside the table. What would happen? It does the rehash. Rehashing will keep the elements in the new elements. So there is a old hash, there is a old table, and there is a new bigger table. It reinsert from the old table to the new table, and there is a lot of things happen. Okay, with respect to the set. So basically, what you need to understand is inside the set, every element inside the set, every element inside the set is hashed. 1 minute. Every element inside the set is hashed. For example, if I take this, because these concepts are very important even for the dictionaries. Let me try to explain. So, what exactly happens is it's more of a sorry. What exactly happens is it's more of a thing. What we call it as, it is called as a slot. There is a concept called slot. You need to understand couple of concepts. Slot. There is a concept called table. Okay. There is a concept called load factor. There is a concept called rehash. There is a concept called hash. What else? Okay, what is called slot means in the hash table, a table is created with a some number of elements. Okay, a table is created with the number of elements. So how many slots are there? How many? What is the default size of a table? So the default size of a table is generally 8 slots would be there for the table. You can have generally there are 8 slots. When you create a set, for example, when I create a set S1 equal to set, when you create a set, what happened? The table size is 8 slots. This is very, very important. The table size is 8. That means 8 elements can be used also from slot 0 to slot 8. Why 8? Why not 4 or why not 6? Why not 7? Because generally computer algorithms work based on 2 to the power of. Why 2 to the power of is 2 to the power of is very good operation for these shift operators. They can always move the bits in the right shift or left shift operation. Generally, shift operators can easily perform 2 to the power of. Okay, 2 to the power of is very good operation. So exactly what exactly you say that S1 dot add of, for example, 10. What happened S1 dot add of 10? Okay, if you create S1 dot add of a 10, first of all, it creates a simple hash. Okay, it creates a simple hash. So there might be some kind of a hashing algorithm that would create a simple hash. Let me check for the, I think hash of 10. Let me check. Hash is a function. It may give some kind of hashing algorithm. It is giving us, the same thing. Generally, if you really look at the hashing algorithm, what it does is, I don't know why it is not giving hash. What hash returns the hash value for the given object. Two objects that compare equal must also have the same hash value, but the reverse is not okay, whatever it is. What exactly it does is it takes the hash. So technically speaking, for example, you take 10, it takes the hash, that means hash of 10, and size of, size is what actually, size is 8, or table size is 8, so 8 minus 1, that means 7. So what it does, so this is a modulus operation. Basically, this is a modulus operation. Index equal to, you get to see that there is something called index. Index is 2. What this operation is nothing but 10 modulus 8. You see that 10 modulus 8 is also 2. For example, so what would happen? For example, I gave 100. You got 4. 100 modulus 8. Also, so this is equal to this. But why this instead of this? This is a bitwise operation, which is really very good operation, which is a bitwise operation. Okay, bitwise operations are very fast. That's the reason they always do bitwise operations. So what happened is some number and operator of the other number, you get some other number. As simple as it is an AND operation. Okay, that means print of 100 bitwise AND of 7. You get 4. This is what exactly happening. Why 7? Why not 8? Why 7? That is also very important. Why 7? Why not 8 is very important. Because of the index, that is something. So actually it uses some kind of a bit masking. There is a concept of bit masking. Okay, if you want to know the concept of bit masking, for example, if you take the 8, I don't know how to print it in binary format. Let me check let me check how to print the elements in a binary format. Uh, Print a number in binary in Python. Go I know, but Python I don't remember. You get to, I'll tell you. Okay, so there is no direct function or what? Bin function converts integer into binary. There is something called bin. You see that if I take a value bin of 8, if I take a value bin of 7, you see the difference between bin of 8 and bin of 7. See, bin of 8 is 1000. You see that bin of 8 is 1000. Bin of 7 is 0111. This is what exactly it wants. The bit masking, for example, 100 and 7. What exactly you got? How do you get 4? For example, I give 10 and then 7. How do you get 4? I'll tell you. Print of bin of 10. Print bin of 8, 7. If you really see that, so what do you get bin of 7? Bin of 7 is, sorry, bin of 10 is 1010. Bin of 7 is, bin of 7 is 0111. If you perform AND operation over here, if you perform AND operation here, what would be the AND operation result? 1 0 or 1, 0 and 1 is 0, 1 and 1 is 1, 0 and 1 is 0, 0 and 1 is 0. This is what you get. You are performing AND operation here. So ultimately what you get? 0010. What is the meaning of 0010? Print 0B0010. If you print 0B10, you get number 2. This is what exactly you get the result as 2. So why 8 minus 1? Why do they perform 8 minus 1? 16 minus 1. You also see 16 minus 1 is 15. Print bin of 15. 16 8 8 16 16 to 32. Print bin of 31. You see these numbers 7, 15, 31. These, you see these numbers, you understand the whole logic about it. These are very good numbers for masking. You see that 3 ones, 4 ones, 5 ones. These numbers are 16 minus 1, 15, 32. Otherwise, the last one is 32, and 64 minus 1, which is called 63. These numbers are pretty tricky numbers. You see that they give 1111. These 1111 would give you the masking with AND operator. Masking means whenever you perform AND operation, this would give you some better number. That means this kind of operation. This is 10 and 7. This is 10. This is the binary value 10. This is the binary value 7. So when you perform AND operation, you get a value 2. Exactly, you do modulus operation also, you get 2. Whatever you get the result here, even you do modulus operation, you get the same result. But what is the difference? Why can't I do modulus operation? Yes, you can do modulus operation. Nobody is forcing you to do normal operation. You can obviously do modulus operation. But why are we not doing modulus operation? Is modulus operations are quite fast. Sorry, quite slow. Bitwise operations are very fast because they are changing at the bit level, and from the microprocessor point of view, they are very fast. They are very fast. Okay, that's the reason the index is. So what is the meaning of this? This is the index. 4 is the index. 3 is the index. 5 is the index. When you get the index, within the index, that value is stored in the table in the 8 slots. Whenever the table would go more than 2/3 of the table, that means out of 8 index, 2/3 means I think 5 or 6, 5 I think, automatically the table size doubles. So if you really technically see that table size doubles, what do you get it? You get 16. 16 doubles, you get 32. 32 doubles, you get 64. So 64 minus 1, 63. When you want to mask it, 63. What is the value of that particular 63 masking? The 63 masking is last masking is, wow, you can get it as 1111 kind of a thing. So all these things are interdependent. These are all depending on each other. Okay. That's very, very important that we need to understand. The same logic applies even for the maps. So people ask why sets are very fast. You know, we use sets very well. In particular in Python, the concept of sets are there only in Python. You don't get in Go or I don't think C C++. We use sets a lot. Why sets? Question number one, sets are because sets are very fast. Why they are very fast? Fast in the sense what? Fast means fast retrieval, fast insertion, fast retrieval. Maybe insertion happens quite rare, but retrieval happens very frequently. You get the value from the set. Okay. So when these kind of insertions, retrievals happens from the set, it is very, very important uh, to understand the internal mechanism of the set. So number one, you understand why the table size is 8 and then it is doubled. It is doubled because they want a number which is always would give the mask of last numbers are 1111. That's the reason they always double the size. Okay, computer algorithms work very well when you double it. 2 to the power of is a magic number for computers. That's the reason even the RAM and all we say 16 bit, 8 bit, 16 bits, 32 bits, 64 bits, something like that, 128 bits, something like that. We don't say 50 bit or 100 bit because the 2 to the power of is always a magic number for computers. Why it is a magic number? You can mask them very easily. You can perform and or operate shift operations very easily, left shift, right shift kind of operations very easily, which is very easy to perform these kind of operations when the numbers are 2 to the power of. So 2 become 4, 4 become 8, 8 become would not become 12, 8 becomes 16, 16 become 32, something like that. So these numbers are very, very important with respect to computers. That's the reason we always use these kind of things. I hope you understand why really uh, we use these kind of things. Okay. Coming to the next concept, which we call it as a dictionary. I think we are good with this sets. You can do more on sets. I will try to upload a lot of things with respect to sets. So the next one we have to use the dictionary. I would like to just start dictionary and then I will uh, sorry. Dictionaries are same like sets, but the dictionary contains key and value. Okay, dictionary is also hash based algorithm, same like set. But the difference between dictionary and set is set contains only the index it requires. It's kind of an array, but dictionary can make maintain multiple arrays, parallel arrays, may contain parallel arrays because dictionary contains keys and values. Values are mapped to the keys. That's what the concept is. For example, I give codes, pin codes is something like that. I give a dictionary, maybe 560086. I can give it as Bangalore 1, for example. It may not be Bangalore 1. 560096. For example, I give it as Bangalore 2. 560034. For example, I give Bangalore 3. 695401. I give it as Trivandrum 1. 522001. I give it as Guntur 1 and all. you see that this is a dictionary. Why it is a dictionary? It contains key and value. The concept is same like set, but only thing is it contains keys. Keys are unique, immutable. What can be a key? A key can be a string, a key can be a integer, a key can be a tuple, etc. As long as you can perform equal to operator, I think that can be key. Values can be any Python object. Any Python object can be, here I gave only only string, but value can be any Python object. Okay. So basically that is how you try to give a thing. How do you try to access for key comma value in pin codes dot items? So again, items is what actually the iterator. You got to get key and value. You can print key is k, comma value is v. Okay, you can get keys and values. Key and value you got to get. Python script.py, you can say values and keys, you got it. Okay, you got key and value from that. So the internal implementation also same. Okay, what is the table size? I don't know how do you get the table size. Let me check. Print pin codes dot pin codes dot. There is something called keys clear keys updates. I'm just checking. Is there clear get items? No. I think length is going to give you only the length is going to give you only the thing. 5 is the line number of elements, but okay. Assume that the it's not assume, but basically it starts with the table size as 8. So that's what actually the dictionary is. So it contains an index table. It contains the entry array that where you get all the elements. Again, the same concept. Index array, we call it as a sparse array or something. That array would store only the indices, not the actual data. So how it works is it is ordered dictionary. Remember that dictionaries in Python after 3.6 or 7 version, it is called as ordered dictionary. Once upon a time, this was not ordered dictionary. These were all unordered dictionary. Now it is an ordered dictionary. How the index is calculated? Take the value key, maintain the hash, get the index, store that inside the table. That's the so the index table. There are two structures are maintained internally. The index table, which is called sparse array, and then the entry array, which is really maintains the real data of that array. So what they maintain is they maintain parallel arrays. Parallel arrays means the index is always given back to this particular value. The zeroth index is always given to the zeroth value, something like that inside the array. Okay, so that's what actually dictionaries are not linked lists. They are very cache friendly, pre-computed, or things are stored. 3.7 or 3.6 onwards, they are all ordered. So keys must be hashable. There are no duplicate keys you can give. Okay. Order is preserved. Order is preserved means order is preserved based on the insertion order. However, they store whatever the index, but they internally it maintains some insertion order is maintained. So based on the insertion order, when you try to pull the values also, it tries to pull all the values from this insertion order. Okay, so the difference between dictionary and set is dictionary has got key and value, set has got only keys, there are no values. and all. We will discuss a lot about dictionaries in the next concept. Okay, let's go for the next concepts. However, we will have the uh, thing every day, so we will go for that in the next concept. Okay, you can also get print of pin codes of 560086. You can directly get a value. You can directly get a value. Okay. What if the value is not there? For example, what if the key is not there? Key is not there. It's a key error. So you need to use try catch kind of a mechanism if key is not there. Okay. So so obviously you may get a key error kind of a thing. You can also assign a value pin codes of 560086. You can reassign a value equal to Bengaluru 1. I just changed the spelling. Okay, and then I would like to get the value so it gets updated. Bengaluru is what actually I give, it got updated. You can give the key assigned to the value. That I can also do. I think I can also use pin code dot get off, for example, 560086. You get a value. Get also, some people use this get function, get a value. What if I don't give, you get none. So the benefit of get is if there is no value, get would give you none. But this one would give you, if there is no value, this would give you a runtime error. It throws an error. That's the difference. So get is safe. If get is not going to get anything, I think we can give zero. I think so. It gives zero. You can also give default value. Okay, with the get, what is the benefit of get is get if no value, it returns none. But this one, if no value, it raises, it throws here. So you need to handle the error here. You don't need to handle anything here. You can understand, okay, if none kind of a thing you can do. Okay. This is how you work with this is how you work with basically dictionaries. We'll see more about dictionaries tomorrow. After that, you go into the kind of a object-oriented programming. We see a lot of things. Okay. So that's all for today. Any questions?